Welcome to this week's episode of ClueCon. Joining us this week is Joe Mordica, the CTO and founder of VOXO, and very much an expert in all things networking and DevOps and scaling. And I'm very interested into hearing what you have done with Kubernetes, because that's a hot topic. I just came back from a conference, and everybody is mentioning Kubernetes, but nobody seems to have really implemented Kubernetes in large-scale telecom applications. So I wonder what the difficulties are or what else. So thank you for joining us.
Yeah, thanks for having me. It's been quite a journey for us to get our workloads to Kubernetes environment, especially without customers noticing. So maybe we can dive into that a little bit.
So, well, would you like to give us just a quick introduction about yourself?
Yeah, for sure. So Joe Mordica, like you just said, I'm the founder and CTO of VOXO. Started VOXO about 8 years ago because I just recognized how broken the telecom industry was and lack of innovation, and customer support was very difficult to come by, like real good customer support. Nobody understood their invoices, what all the fees meant. So I just kind of set out on a mission to fix all of that in the industry, and it's been quite challenging to keep things simple for the customer, but still be profitable and still provide a really good service to customers that added value to their organization. So it's been fun.
The word you use, profitable, is really perfect in this environment, because many people get enamored with the newer technology or a new way of doing things, etc. And then fast forward 6 months, you have the same product, but it's 10 times harder to manage, and you haven't done anything else but making it more complicated. So, well, cool. So where did you start? Did you start from scratch? Do you have an existing platform?
I actually started with FreePBX years ago. And after about 10 customers and managing a bunch of different contexts, I knew that was not going to scale. So I actually bit the bullet. And because I was scaling faster than I could build, I bought BroadSoft and deployed BroadSoft. And then when I figured out with BroadSoft that I couldn't build the things I wanted to build to provide the customers the features they needed, I started building my own at that point, using Camelio, Asterisk, RTP Engine, kind of that blend, and MySQL. So that is still kind of our primary stack that we use today. It just looks a lot different than it did, 6 or 7 years ago, whenever it was being built. But that's the biggest kind of differentiator between like us being able to perform in the market versus us just kind of offering everything that everybody else is offering. Like when you build your own solution, you get to kind of decide what direction you go, and we're a UCaaS company now, so it's UCaaS and contact center is what we're building, and it provides us a lot of freedom, and how we build new features for customers that add value versus just having to go to BroadSoft and say, hey, can you build this, which they're obviously never going to do. But yeah.
That's so speaking of your current Kubernetes deployment, is that born out of an existing application, or did you start from scratch just designing the thing? Like, first of all, what is the application running? Because that's part of how you deploy it, right?
Yeah, so the applications that we're running in Kubernetes, we're running our whole stack in Kubernetes. There's not a single thing in our application stack outside of Kubernetes, even our databases.
That's interesting. That's not super common.
That's right. So we started by Dockerizing all of our applications into Docker containers. And then we ran those Docker containers in our bare metal environment. So we had, co-location in Atlanta, Chicago, a few different co-location facilities with our own bare metal servers. We just deployed those Docker containers in those environments to learn and understand how they were going to work in Kubernetes, hopefully. And then eventually we, built up the nerve to start deploying and building some of those YAML Kubernetes files in GKE, Google Kubernetes Engine. And we just, over the past probably 2.5 years, we've slowly been testing and migrating and testing and migrating. So we actually had our bare metal environment hooked up to our GKE environment from a network perspective so that we could put certain customers on Kubernetes and back on the bare metal environment as we learned more about the infrastructure, so that whenever we migrated all of our customers, they didn't notice anything was happening or taking place.
Well, yeah, that's, I mean, 2.5 years sounds like it's actually a reasonable time frame for an implementation like that, because it's not super easy. What were the hardest parts to manage? Because, running web-based workload, functional like stuff, even I do that, to be honest. Even I'm not a DevOps engineer anyways, but the function-based stuff, etc., is, it starts, it does what it needs to do, it stops, and then you're done. But what's the hardest components to run?
The hardest thing to wrap your mind around is kind of the ephemeral state of pods in Kubernetes. So Kubernetes can take down pods at any time and bring up new ones to replace them based on like failure or scaling up or scaling down, right? So you have to account for those failures and pods coming online and offline. And so we had to build our apps in such a way to handle those failures and because obviously if you have calls running on an RTP engine or some media server, you can't just take the server down. You have to have graceful shutdowns on those pods in order for you to not drop any calls and things like that. That was the most challenging part.
And how, I mean, what decides whether a server needs to go? Like, a healthy server that's running a call should never be deleted, or does it happen anyways? Just find my
right.
My head's around it.
It should never be deleted. Like if you're running in a public cloud like Google or AWS, they could have an issue with a host machine, and that host machine could go down. But what's nice is Kubernetes allows you some graceful shutdown period, and you can choose that. I'm not going to shut down this node until all the calls are dried up, on that node. Things like that. And then there's other things like upgrades. So if you want to upgrade your Kubernetes version, your nodes, Kubernetes will rolling restart your nodes. And so you need to be able to handle those upgrades as well in Kubernetes. And then if Kubernetes decides to move your workloads to another node that is underutilized, let's say you have a node that's like overutilized from a CPU perspective. If Kubernetes needs to move that node to that pod to another node that's more underutilized, then that would be another shutdown scenario.
So it does move, Kubernetes will move your servers around according to resource utilization.
And based on your config. So you can tell Kubernetes to not evict your pod whatsoever from that particular node, but we want to take advantage of the things that make Kubernetes great. And that's one of the things that makes Kubernetes great, is its ability to balance your workloads on the pods in such a way that you don't have one or two machines that are taking all of the resources.
I agree that if you're going to use something like Kubernetes, which is already an order of magnitude of complexity harder than, saying, doing straight up Docker or whatever, if you then start disabling half of it, you end up in the state you described earlier, where you have something that's more complicated and doesn't do anything new.
We had to make a decision. Like if we're going to go all in on Kubernetes, then we have to take advantage of Kubernetes. We can't just like start deleting all the stuff that makes it great and like revert to this kind of old school bare metal way of managing our servers like pets. Like we have to think about our servers like cattle, right? And and just use the resources, think about it in a different way. And that's difficult to do with very stateful workloads.
Of course, maybe you cannot say everything, but what stack are you running on there? Like, which components do you have running?
Yeah, so everything that we are running on Kubernetes is actually publicly available on our GitHub, and it's visually represented on our website in a nice little 3D diagram view. I can yeah, so all of our components are exposed publicly. I can put it in the chat here or share my screen or something and just kind of. So this diagram
Oh,
shows
wow.
you. This is actually on our product page. So if you go to voxo.co/product, you go all the way to the bottom of this page, and you'll see this really cool visual diagram here. And you can drag around and see all of the components that we're using in all 3 data centers live in real time. So this is our whole stack. And you can click on these components individually and get a little description of what their responsibilities are here on the left side. So for instance, these 3 blocks here, these 3 like green, yellow, and blue blocks represent physical Google regions, east, south, and west, or east, south, and central, I think. In each of these regions, we have an exact mirror of each other. So all regions run all components equally, and all regions can handle any failure from another region. So it's all one cluster in multiple regions, and really it's globally scalable. So nothing in our stack prevents us from scaling to 4 or 5 or 6 or 7 or 20 regions. These are all of our components: RTP engine, Kamailio, our API, Proxy SQL, Astra's present servers, various sidecar apps, MySQL orchestrator for managing MySQL, Nats for Nats is kind of the glue that is our messaging bus that connects all these services together. And then these are the external services that we use for various other things like cloud storage and monitoring and BigQuery for data for HTAP type queries. So that's kind of our stack, and then we support WebRTC clients through the Google global load balancer here, and so this is how clients connect from the desktop app or mobile app, and they will route to the closest facility in proximity to them from a latency perspective.
I see you have a lot of open source components in there. How predominant is open source in your infrastructure?
Every single thing that we deploy in our stack is open source. Not a single thing that we deploy is a paid piece of software. And then anything that's not open source, we build ourselves. Usually, they're JavaScript, like Node.js apps, or really JavaScript apps. I mean, so it's either open source or it's JavaScript in our environment.
That's incredible. Yeah, I think this is one of the. First of all, I need to say this is one of the coolest diagrams I've ever seen of an architecture anywhere. So whoever did this, it's incredible. But it goes a long way into showing what impact open source has and what we can do. Like there's entire companies based on essentially open source, and it looks quite nice too. Cool. So I see Camilio. I see. So you say you're running on a mobile app too. Just curious, just to finish what your stack is. What's your application mobile app development?
So our communication stack. So I guess you're familiar with JS-SIP.
Yes.
Yep. So that's in our mobile app environment, and our desktop environment as well. Just uses WebRTC over SIP over WebRTC to connect to the Google load balancer, and then the Google load balancer takes that traffic to one of the Camelio instances in our data center. So Camelio is the only component in our data centers with public IP access.
Yeah, that makes that's sort of similar to some of the things we do at SignalWire. So it's striking how if you start from different sides, you end up with a few solutions which are right solutions, right? There is a limited number of correct solutions, right? It's kind of like it's kind of like math. Like at the end, 2 + 2 has to equal 4. Doesn't matter how you sum it. It's very, very striking. And how many people have to manage infrastructure? Like talking just the DevOps part, no developers.
Well, now it's a lot less because we're not managing bare metal servers and our stack. So Kubernetes handles a lot of failures and all that for us. So it's really just 1 or 2 people that manage this whole stack. So they can handle deployments, they can handle upgrades, they can handle maintenance, they can handle any monitoring events, respond to alerts in Grafana, Prometheus. So all of our metrics are collected via Prometheus, pushed into Grafana. We have alerts for every single thing that can happen, an event, and we're essentially it's 1 or 2 people that can manage this whole stack.
So 1 or 2 people manage this entire thing?
Yeah, it's really on the DevOps side. Yep. It's
mind-blowing. I mean,
but so in our bare metal environment, that was not the case because we have hard drive failures and we had, all of these networking issues that would take place. And then we had, you name it on bare metal servers, the types of issues that you can come up with. And then deployments are way more difficult because now you're SSHing into machines and you're, having to manually deploy software and make sure that you don't have like config drift between all of your bare metal machines. Whereas in this environment, we have a little CLI, management CLI that we just do rolling restarts, and Kubernetes handles those rolling restarts for you. So you don't have to manually dry up traffic on nodes. Kubernetes does that for you by using the graceful shutdown mechanism.
So I do have a very specific technical question, but looking at the diagram, you probably know, and you've certainly tried being a DevOps person, you probably tried to run something like Asterisk or RTP Engine or even FreeSwitch on Docker, and opening up the port ranges is practically impossible, right? Because it takes an hour to go up and an hour to go down every time, and it almost defeats the whole point. So you end up using network host mode so that you don't have to open up the port ranges. Does Kubernetes have the same issue, or do you handle that differently in Kubernetes?
Well, one nice thing is that our, like you said, media servers, Asterisk, FreeSwitch, they don't have public access. So they run internally on the internal Kubernetes network. So you don't need to run the host network flag on those pods or containers. We just, so basically Asterisk, FreeSwitch, all of their ports that they're listening on for RTP or for signaling are all accessible over the LAN. So that's nice. So you don't have to deal with ports and those media servers. RTP Engine handles the relaying of the media between the SIP client on the WAN and Asterisk or FreeSwitch on the LAN, LAN.
So that's very interesting. So that is a difference with Docker, because in Docker, no matter how you run things, like if you connect the service to the internal network, you still need to find a way to open those ports. Like it doesn't matter which network it is on. So that might be a very good reason alone to start looking into Kubernetes from a telecom and managing large port ranges perspective. Because frankly, all we do is manage large port ranges in the end, right?
That's right. So it allows FreeSwitch and Asterisk to scale horizontally inside your LAN, inside your network, because RTP Engine handles media relay very well and at scale. And if that's all it's doing, instead of, you know, Asterisk and FreeSwitch is handling voicemail apps and queuing and all of the CPU intensive stuff, where RTP Engine, being on the edge, has a WAN NIC and a LAN NIC, and it can bridge the media between the WAN and the LAN, so you don't have to worry about those port issues, in like traditional Docker environments using the host network.
I'm curious what the load balancing looks like in this scenario. Can you just any information you can give us on how it works?
Yep. So even though this single Asterisk instance is visually represented as a single instance, this is horizontally scalable. So there could be 4, 5, 10, 20 of these Asterisk instances here at any given point. And Camelio is responsible for using the dispatcher module, load balancing the incoming invite request to Asterisk or FreeSwitch. So if you have 5 or 6 FreeSwitch instances, Camelio will, using the dispatcher module, do round robin between those instances and try to balance the load evenly. So one of the really nice things about Kubernetes, though, is it can react based on CPU. So if this Asterisk or FreeSwitch instance is 80, 90% CPU, Kubernetes will add another instance for you, add it to the dispatcher module in Camelio, and Camelio is now aware of the new instance and can start loading calls on it. And then at the end of the day, when the traffic kind of is less than the traffic during the day, like the traffic kind of goes back to a normal or less than state, Kubernetes will remove those resources, so you're not spending money on VMs that that's kind of getting wasted. So that's one really nice things about Kubernetes, is that during the day when traffic is high, it may scale to 10 or 12, 13, 14 FreeSwitch or Asterisk instances, and then at night, as the traffic goes down, it will remove those VMs and gracefully dry up those servers for you.
And I assume there's ways to prevent it from going below a certain number. There's minimum available instances. It works kind of like the AWS autoscaler, I assume.
That's right, min replicas. That's right. So you can find all of our configuration here on our GitHub for all of the components that we just listed. So you can see exactly how we're doing it, how we're kind of cooking the bacon, right? So if you click on Camelio, you can see the daemon set configuration here and kind of dive off into the config and see exactly how we're deploying these components into Kubernetes.
It is incredibly interesting that you're releasing all of these to, the open to be looked at. And what prompted you into thinking, well, let's release everything? That's not common.
Yeah, it's like, hey, I wish that I had something like this to fall back on when I was building, what you saw. So like, I know that other people are thinking that same thing. Like, I wish there was some type of example to look at, even though, and this is just an example, like, even though we may not build it exactly like somebody else or deploy it like somebody else. Like, I want to see all of the pain that someone went through, and came up with what they did in order for me to base my platform off of and my deployments off of. So this is probably 2 to 3 years of pain is what you see, coming together to a nice deployable, maintainable configuration.
That's really nice. Yeah. You're right. Having something to fall back on is something that we all would have liked having back in the day when we started, for sure. It's really interesting. I think I'm going to try and start learning some Kubernetes. Speaking of which, How long did it take for you to learn? Was it a hard experience? What can you tell us about learning the whole thing?
I think you'll never learn Kubernetes. I,
That,
I mean,
that's encouraging. Okay, yes.
yeah. So I've been digging for quite some time. I'm fairly familiar with the things that I need to be familiar with that attribute to our environment. However, there are so many things that I don't know about it. I think what's important is like going through the process of understanding what you want to accomplish and then going and researching and solving those problems. They have good documentation. Now there's so many people talking about it. Now we have this for other telecom operators to look at from a reference point perspective. That if I had this, I could have done what I did in half the time. Just because I I fought through a lot of this stuff and broke a lot of stuff as a result of just not knowing and not reading docs and just trying stuff. And that was, I think a good solid year of trying and breaking and understanding is going to give you a really good confidence in a Kubernetes environment.
Wondering, so, and what do you think will be a good resource to get it started? Like, okay, I see, picture I like doing this exercise with guests. Picture you're watching this video and you really like what Joe has been doing with Kubernetes, but you know nothing about it. Say you are someone like me. I know how to pull up a Frisbee server very well, configure Camilio, load balance, etc., but not really nothing beyond deploying with Docker, which is standard at this point. Where do
Yep.
I go?
Yeah, kind of like what you were saying. So like you have a few things in mind that you want to accomplish with Kubernetes, right? Like a load balancer and specific things like that. Well, like I'm kind of a YouTube junkie, so I'll go on YouTube and watch like Google or like I'll watch like Kubernetes videos on ingress or load balancers and like kind of get really familiar with that. Just watching different people's videos and their different angles of talking about it. By the way, there's no videos that you can find on hosting telecom applications in Kubernetes with like actual config. So that was kind of a bummer for me when I started. But taking those primitive components of Kubernetes, like the load balancer, a pod. What is a pod? What is a workload? What is a stateful set? What is a daemon set? And just taking all of those primitive components and going and just learning as much as you can about those specific things by looking at YouTube videos or whatever. That's kind of that's a good place to start. That was a good place to start for me. Is I have to understand like the things that I'm going to be deploying, and it's not I just laid out all of the things, stateful sets, daemon sets, deployments, workloads, pods, containers. Those are the components that we've deployed, and so those are the things that I had to learn really well.
Do you think running on Google Kubernetes engine makes things a little bit easier, at least to start with?
Way easier. I mean, light years easier. If we had to deploy our own Kubernetes environment on bare metal servers, I probably would have just stuck with bare metal.
Okay.
It was that big of a deal. Yeah.
So running outside of GKE is not recommended, both.
Yeah, and actually GKE specifically, like AWS, to get multi-region deployments in AWS, I mean, you have to set up VPC peering. However, like with Google, all of your regions are in a single VPC. They're already connected, so you don't have to do any networking. It just works. So you deploy in one region, another, all the pods have access to each other. It's beautiful. We found that GKE versus AWS or EKS was light years easier and more maintainable from an upgrade perspective for our engineers and for ourselves to really understand as we were getting into Kubernetes.
I heard it mentioned from multiple people that the AWS, so EKS, I think, version compared to Google Kubernetes engine, the AWS version is almost not worth using over just running some EC2 instances and spinning up your own thing, because at least that way you really know what's happening.
That's right. Yeah, there's definitely a lot of magic on both sides, GKE and the AWS side, when setting up Kubernetes, because they set up the master node for you. You don't have to manage that. They manage the upgrades on the master nodes like Google does. So they do a lot of what I call magic. So you don't have to like figure out all of the stuff that you know is taking place in the background.
There's a lot of magic, yeah, for sure. But at least, I mean, yeah, GKE is something that seems to be really well thought out. Well, they are the ones that created Kubernetes, so it probably makes sense that it's a bit better. But we're starting to use that too. So that's why I was saying that we explored the Amazon version. And what I got from the DevOps people, which all are much more knowledgeable than I am on the subject, is that, well, at the point I'm just running EC2 stuff, and at least I know what's in there. AWS has this habit of giving you cloud formation templates that spin up 24 things, and you never
Yeah,
going on.
yeah. Your bill is $94,000.
Yeah.
Before. Yeah. So it's it was a lot easier for us to consume and understand. GKE was, and they have more US based regions to pick from. So like where AWS has like west and east, Google, like GCP, now has like south, west, central, east. They have quite a few more regions to help us to get closer from a latency perspective to our customers.
Will you say that Kubernetes is a bit like running your own cloud in a sense? That's another sentence that stuck with me when I was talking to people. Like, you only really do this in Kubernetes when you're using Kubernetes, right?
Yep, you can deploy anything you want to with just a simple config file. So you basically have your own.
It's not something you will use with, say, Openstack. It's a different way of doing the same things.
That's right. Yeah, people got excited about Kubernetes because of the complexity and really how much OpenStack, in my opinion, crashed and burned from a complexity perspective. So Kubernetes is kind of the answer that people were looking for whenever they started getting into OpenStack and thinking that it was going to be kind of the Kubernetes environment. But Kubernetes is really the way more simplified from a deployment perspective environment to run your apps in than an OpenStack environment.
If I have to be super brutal about OpenStack, and I'm certainly saying something that's ultimately wrong, it feels like it was a bit shoehorned into the world. Like it's really something people really didn't want to use AWS. So they came up with a version of the AWS that has that ultimately you go run on AWS.
Yeah.
So
that's a good way of explaining it. Yep.
So yeah, Kubernetes is a very, very interesting. And again, well, thank you so much. I mean, there's so much detail in that. So everybody, I know I will. I'll go read through that entire GitHub folder because I'm really super interested into some of the things you've been doing. Take a look at the website. VOXO offers communication solutions for middle to large size customers. But one last question: how many calls are you running on your Kubernetes cluster on a day, like an average, not just a ballpark?
We're in the low thousands. So couple thousand at any given point, and those calls could be happening at any region. Those are simultaneous calls. So like total probably total.
Yeah, it's hard to say.
Yeah, it's hard to say, but probably 200,000 or 300,000 per day, something like that, and then
but a few thousand concurrent calls are impressive. I mean, at that stability, at that rate, especially given you're approaching 1 call per second levels of traffic, which is not super. There's nothing to scoff at. So really, well, I mean, first of all, well, nicely done. That's something that I truly deeply admire. Plus, it's all built on open source, and it feels like there's something to learn from there.
Yep, it's been great. It's been a lot of pain and a lot of victories and a lot of pain, but it's been great to see it come together and be used in a production environment.
So you mentioned you spoke at AstraCon. Are there any other conferences you're planning to speak at in the future?
We actually just talked about doing ClueCon. So I think it would be, we may do it this year and may kind of do this talk or some version of this talk. And I think that would be really fun to get some feedback from the group. So we may end up doing that if you guys have some spots available, but for sure next year, we'd like to do ClueCon. We'll do Camellia World probably next year as well.
Well, glad to hear that we might see you at ClueCon. By the way, ClueCon is, for the people who don't know, is in Chicago from the 14th to the 17th of August. There are plenty of interesting talks, including maybe Joe talking about the VOXO Kubernetes setup or many other similar, very centered on open source, very centered on real-life telecom deployment. So come join us. It's always very fun. Well, Joe, thank you so much for joining us today.
Yep, absolutely. It was my pleasure. Had a lot of fun with it, and thanks for the invite.
Looking forward to seeing you at ClueCon or some other conferences.
For sure.
And for the rest of the people, I'll see you next week. Goodbye.